Alright, so I have here a little balanced ternary calculator. I have it running over here. So it knows things like pi. You can convert that into balanced ternary. It knows things like E. And we can do things like, we can give it expressions. Things like that. We can reset the number of digits that it will give you after the decimal point. So now if we do like 1/17, it just gives you 0, and it's capped to 32 because that's about the precision that we got here. So now yeah, see right there, there's a little error, and it actually 32 might be too high then. Maybe it should be 31. I was having an issue with this, so if I do 1/3, 1/9, 1/27, 1/81, I was having an issue with these zeros here disappearing because of this while condition. Because what happens is, like, you'll process to here and then you get a 0, which means it drops out of the while. So what it would do is it would give 0.1 for all of these. So here's a little, this fixes it. You might think, well, you could just do a for loop, but that gives you problems out here for larger values because you don't know how many digits that's going to need necessarily. So in a sense, this is not primitive recursive quite. It's basically is, but not quite. So yeah, there's this little correction thing. But yeah, for the most part, it works pretty nicely. Give it something a little more reasonable, right? So like 1/2, 1/3, 1/4, 1/5, 1/6, 1/7, 1/8, 1/9, right? And we can do pretty big numbers, so it's like exponents. 17 cubed. Yeah, it works pretty nicely. So I have that linked in the description.